Welcome to our high school assessment review. This problem is taken from the 2009 public release item in the state of Maryland. The question is, which equation best models a line of best fit for this data? So we are being asked here of the equation of the line of best fit. So we are asked to select from these four equations. Let us first analyze what is given. So what we have here is a table representing the students typing. The first row represents the number of minutes, whereas the second row represents the number of words typed by the student. So what we have here is a pair 2 and 122. This means that a student typing for 2 minutes will be able to type a total of 122 words. If that student typed for 3 minutes, he would be able to type 182 words. For 4 minutes, 240 words. Notice also that there is a jump from 4 minutes to 6 minutes here, and therefore you can see a considerable jump in the number of words typed for 4 minutes and for 6 minutes. Now, with that as our analysis, let us recall what we mean by the line of best fit. Let us plot these given points. Now, what I'm going to do is just a rough sketch of the points, just in order for me to be able to quantify, to visualize these numbers. So, along the x-axis, I'm going to put the time in minutes, and in the y-axis, let's put the number of words typed, or the W. So for my scale, I'm going to start here with 1, 2, 3, 4, 5, and 6. I'm going to end at 9. 7, 8, and 9. For my y-axis, notice that the highest number is around 538. It's 538, so it's about 600. So let's go up by 100. The scale in the y-axis is 100 units. So this 100, 200, 300, 400, 500, and 600. So in order for me to be able to include all these points in the y-axis, so let me label that one. 1, 2, 3, 4, 5, this 4, 6, 7, 8, and 9. And here I have 100, 200, 300, 400, 500, and 600. So where is the point to 122? So this is 122 is about this point, just this, an estimate. 3, 182. So 182, 3 might be here. And then 4, 240. So this 200, 240 is somewhere here. So this could be 4, 240. Then 6, 368. So this is 200, 300, 368 somewhere here. And then 6 is about this point. And the last point is 9, 538. So this is 500, 538 somewhere here, and the 9. Now, where is that which we call as the line of best fit? In order for us to have a line of best fit, there are some assumptions. The first assumption is when you look at the scatter plot, the alignment of points should look like a line. Otherwise, there is no point of computing for the line of best fit if there is no line. But you notice that in this given table, the points look like they are forming a straight line. So that means it is valid for us to get the equation of the line of best fit. So, second assumption, that line which you call as the line of best fit is just not any line, but the line that can include most of these points, if not all of those points. So, how do we draw now that line which you call as the line of best fit? Let's use a different color here. When we draw the line of best fit, some of the points might be above, some of the points might be below that line, but that line should best approximate the alignment of points. Also, when we get the difference between the point and the line, the distance from the point to the line above the line, and the distance of the points to the line, of those points below the line rather, we'll be able to get zero sum. Because some of the points are above, some of the points are below. When we get the sum, there would be positive distances, there would be negative distances, and the total distance would be zero. So, how can we now get the equation of this line? There are so many ways of doing that. By inspection, you can look at the increase here. From 2 minutes to 3 minutes, there is an increase of roughly 60, about 60 words. From 3 to 4, there is an increase of how many? About 58. From 240 to 368, there is an increase of about 128, but there is an increase of 2 on top. And then you can get the difference here. So 60, about twice 60, because there is an increase there of 2 units. So we can also say that the slope is close to 60. Which among this line has a slope of 60? 3m has a slope of 3, 60m has a slope of 60, 102m has a slope of 102, and the last equation has a negative slope 117. So if I am the one taking the test, even without computing exactly for the line of best fit, I would be picking choice letter B. But in our review, we are not after the right answer only. We are after our understanding of the concept, so that when we encounter the same problem in the test and there are some changes in the data, we'll be able to figure out how to solve our problem. So what I'm going to do now is I'm going to show you how to compute for the equation of the line of best fit using our calculator. Because in real life situation, most often we'll be dealing with problems where the slope is not as close to 60 like this. It's not constant. You'll be dealing with variation here. You'll be dealing with variation on the differences in the other axis, the x-axis. So here's my calculator. Let's put the equation in our list 1 and list 2. So in our list 1, we're going to put 2, 3, 4, 6, and 9, or the number of minutes. You look at this area, that's where the history of the keys that I am pressing can be seen. So how do I access the list 1 and list 2? So I press stat, and then I'm in edit. I just click enter. So that means I'm going to do the editing. In my list 1, I'm going to put the time in minutes. And as I said, it's 2, 3, 4, 6, and 9. 2, 3, 4, 6, and 9. In the list 2, where I'm going to put the number of words typed, 122, 122, 182. What's the next? 240, 368, 240, 300, 68 and 538. Okay, so we now have our data. Let's visualize these numbers. Let's look at the scatter plot. So I do that by going to the scatter plot. To access that scatter plot, I have to press the second button first, second, then is y equals. You now have here the stat plot. So I just click on enter. And then notice that the current or the default setting here is off. So I have to switch this on. The scatter plot one will be switched on. And then I'm going to select the type of graph. I'm going to select this first one, the scatter plot. So since it's already highlighted, I don't have to go down there. In my X list is L1, which is the number of minutes. In my list 2, I have the number of words. So everything is now set. So I now click on zoom and I go down to number 9 because I'm using the zoom statistics, zoom stat. So you notice now you have how many points here? 1, 2, 3, 4, and 5. These 5 points represent each of these ordered pair. So you have one ordered pair, 2 minutes, 122 words, another ordered pair, another ordered pair, another ordered pair, and another ordered pair. This plot is similar to the graph that we have plotted. Now, for the equation of the line of best fit, there are 2 ways again that we can do this. One is we can place this equation in the y equals and then graph the stat plot and the line simultaneously, and let's see if the line approximates or best represent these scatter points or the scatter plot. Or the other method is we compute for the equation of the line of best fit. In test, it's possible for you to do it by trial and error, plug this in the y equals and then graph simultaneously. But in real life situation, you will not encounter problems where the options are already given. Sometimes when you solve problems, the approach is not linear. We have to do trial and error. We have to, we do not know what are the options, and we just will figure out along the way. So what I'm going to do is do the first option that I'm telling you first, and then we'll do the second option. So let's try this W equals 3m plus 60. Since we are using the function here, we consider this as y equals 3x plus 60. So 3, instead of m, we use x plus 60. Then let's look at the graph. Okay, this line below is the graph of 3m plus 60 equals w. This is the line that we are approximating. Of course, we know that this is not the best line. So we can go to the second equation. We can replace that line, that equation, or we can do that in the second y sub 2, in y sub 2 rather. So let's put 60, instead of m, we use x plus 3. Then graph. What do you notice? Notice that this is the first equation. That's the equation, letter A, W equals 3m plus 60. The second one is the equation, letter B, 60m plus 3. So without going to options C and D, we know that letter B is the right answer. Now, we're going to do the second option that I told you before. If we do not know the options, how can we find the equation of the line of best fit? What we can do is go to stat. So you can see here what buttons I'm pressing. And then we can go to calculate and then select linear regression or you can select number 8, either number 4 or number 8. Let's select number 4. You can scroll down or you can select 4. It's the same thing. So linear regression, the equation is ax plus b. And what are the variables involved? It's the least 1, comma, least 2, second 2, or second 2 to get least 2. And then vars, y vars. The reason why I click vars, y vars is because whatever is the result of the computation here, I want it to be saved in the y equals in the function. So I click y vars function, and then I select where I want to save the result. So I can save that in y1, y2, or wherever. So let me save that in y sub 1. Enter, enter. Notice that there is an error. Now, the error is because, we can go to 2. You look at here, we forgot to put the comma. So I'm going to put, I'm going to insert comma. Second, insert, and then comma. Let's click on the graph. Let me see if I did it right. Yeah, then L1, L2, delete this part. Vars, y vars, enter, enter, enter. So this is now the result. And what do you notice? Our A is 59.74, which is the slope. And this can be rounded up to 60. Our B is 3.2, which is our y-intercept. That agrees with our computed value here. So how do we interpret this? The slope is 59 or 60. That means for every minute increase, there is a corresponding 60 words increase in the number of words typed. What does this B represent? This is the y-intercept. It says that at 0 minute, the student is expected to have typed 3 minutes. It does not make any sense. How can you make 3 words if you are not even starting? So that's one of the analysis here, one of the interesting part here. In approximating the line of best fit, it does not necessarily mean that all the points are on the line. That line is just the model that can approximate those points, and that's the best line that can represent those points. But it does not necessarily mean that it can predict beyond or way up or way below the domain of the given function. If we project for, let's say, 30 hours, and this is just 4 minutes, then this model might not work anymore. If we project also for numbers less than 2 minutes, it's the given table started with 2 minutes, that model might not be applicable anymore. So to summarize our video, we are solving here problems about the line of best fit. And for the line of best fit, there are several conditions in order to apply this. The first one is we visualize the data first, and we must be able to convince ourselves that the points form a line or approximately form a line. If the points are too scattered, then there is no point of getting the line of best fit because there is no line that can best represent them. Then the next thing that's important is that the line that we are going to use to represent those points should be the line that is equidistant to the points above that line and to the points below that line, or the differences between the distance of the points above that line of best fit and below that line of best fit would be 0. And in the computation, they call it as the least square, the method of the least square distance from the points. So also, when the numbers are large, it's important that you know how to do it in the calculator. And the steps that I have followed are these. You can also pause the video so that you can see what are the steps that I am doing when I operate the calculator. So thank you very much.